What we're talking about today is population ecology, and we've already talked about this in class. That's when we did the random population, or estimating the population of a certain area of the sunflowers. And so we're going to talk about this again here. And when we start talking about the population of an area, in this picture we want to look at the number of butterflies, and of course these are monarch butterflies. We could actually, if we had a bucket and had some nets and had a couple of people, we could actually count the number of butterflies. We want to know how many monarch butterflies live in this area. And of course this is something doable, but when you start talking about the population of, say, white-tailed deer in an area, it's not as easy as just picking off butterflies and looking at them. Here we have the human population on Earth, and we see that human population has grown exponentially over the past couple of hundred years, mainly because of medicine and different things has allowed us to live longer and has allowed us to reproduce at an increasing rate. The United States, we use a huge amount of the world's resources, but because of our middle class, our population of the United States has sort of stayed the same. But as you can see, in the year 2030, not only are we supposed to have over 8 billion people, but of course we're going to have less land, which means finding these resources, being more efficient with our resources is something that we're going into. If you wanted to be a farmer, going to Auburn University or Mississippi State, Virginia Tech, to actually learn about farming to get the most efficient yield per square acre, that's where farming is going. Not just knowing how to drive a tractor, just not knowing how to plow a row, but actually how to make your crops more efficient. This slide, we're actually looking at different dispersal types, and the first type, type A, is clumped. When we look at the clumped area, this is resulting from a need for nutrients, mating, employment. So this is what the state of Alabama would be like. We would have a lot of people congregating in Huntsville, a lot of people in Birmingham, Mobile area, and then outside of those areas you might have a couple here and there, but for the most part rural Alabama doesn't have a lot of people. B is uniform, in a uniform or evenly dispersed pattern. This is because the entire area is favorable. The entire environment is favorable. Resources are spread evenly throughout. And then in a random area or random dispersal type, essentially the resources are scattered. The resources, you really don't understand why something may be in a certain area. You may see 2 or 3 here, over here you may see 1, over here you may see 4, but it's just random. You see no apparent reason for the pattern. This picture is just showing the life table, and when you talk about the life table, you need to know about the number of people live at start of the year. You need to know the deaths and the death rates, the average life expectancy, and this just shows how the mortality rate of humans has changed over the years. Here's a survivorship curve, and of course humans have a survivorship curve of 1. Essentially you have high number of young, high number of middle-aged, and then as people get older, of course they do die, so you have less number at the old age. For type number 2, this is a constant decline, and this indicates that the environment is relatively favorable, but the organism may be a food source. So it's just a steady decline right here. You do not have a large and middle age. Pretty much it means that predators are going to eat, young, they're going to eat old, they're going to eat middle age, so you've got all types of ages dying. And then type number 3 is meaning you have many young, few in the middle, and very few old. And what this is representing is in a lot of marine organisms, such as the blue crab, they may release as many as a million fertilized eggs, but only 1 or 2 will ever reach adulthood. This slide just shows exponential growth. Exponential growth, another name for exponential growth, is a J-curve, and here you just see a J-curve. It's in the form of a J, hence the name J-curve. You may actually at some point see an S-curve. An S-curve sort of starts out as a J, and then of course it's going to wrap around back at the top. And this just shows how populations have increased, decreased, or stayed the same throughout history. This is the S-curve, and like I said, the S-curve, we have the exponential growth here. This is the J part, and then the logistic growth as it starts to plateau or starts to flatten out. This is what we hope to actually see in the United States. We want to see that growth actually flatline because, you know, our resources get limited, our jobs get limited, and this has happened in some countries. Of course, you never want this S-curve to actually go back down, but that does happen from time. This is the boom-bust cycle, and this is what we're talking about with going up and going down. In the case of a snowshoe hare, if you look here, as the hare population increases, of course, the lynx population increases here to here. The lynx, of course, is what eats the snowshoe hare. Notice that it starts declining. Notice that as the lynx declines, of course, then the snowshoe hare can start increasing, which then will allow the lynx to actually increase until it reaches a certain number, and the snowshoe hare starts decreasing, which in turn will make the lynx. And as one goes up, the other goes down. But this is a good relationship between predator and prey. This here is the snowshoe hare and the lynx. The lynx is just a cat-like, and then the hare, of course, this is the human growth that's been on Earth, and notice again, because of medicine over the past couple of hundred years, our population has boomed right here, has grown exponentially, which is causing problems. You'll notice that during the plague, there was a dip. There was a plague time in the Dark Ages, early Dark Ages, that it sort of dipped. But for the most part, the human population was somewhat steady, and then right after the plague, as we got to the technological revolution, that's when the population of humans actually started increasing. The industrial and then the technology revolutions what made things increase. Before then, like I said, if there was something wrong with you, even right after the plague, you didn't make it. Our population might have actually been healthier because bad genes weren't passed on, but at the same time, you know, overall, you weren't expected to last long. And then here, countries that have large populations normally have bad footprints or bad ecological footprints. This just means what type of effect do they have on the ecosystem or on the biosphere. In this case, the United States, we use a ton of resources, which is bad. Other places such as Australia, Canada, Sweden, these countries don't use the resources like the United States. So anything above the line here, above the line means that we leave a bad footprint. We're using our resources a lot more than we need to. And below the line is actually a good footprint, or meaning they do not use the resources as much as the United States, Norway. China and India can somewhat be misleading because of their, you have the upper class and then you have the lower class, and they have so many people. India and China, of course, are the two largest countries in the world. And because of their number and because of so many poor people, so much poverty, they actually do not use as many resources as what we do. So their line is actually on the, or their footprint is actually on the line. It's a little misleading in that per person, they don't use as many resources as the USA, But when you look at it country by country, of course, they would actually use more.